So far in Unit 3, we've spent our time talking about different relationships within the angles of the triangles and using those relationships to solve various equations. What we're now going to do is take one of those types of triangles that we learned about on 3.1 and really delve into them. And that type of triangle is isosceles triangles. And the reason for that is knowing that a triangle is isosceles actually tells you a whole bunch more information than you might actually realize. So let's take a look at this first theorem. This first theorem, of course, is about isosceles triangles. Tells me if two sides of a triangle, notice it does not say two sides of an isosceles triangle because we are talking about general triangles so far, are congruent. Oh, now it's isosceles. If two angles of a triangle are congruent, then the angles opposite the sides are also congruent. Okay, now let's take this information and mark it on my diagram. I know that two sides of my triangle are congruent. That is my if statement. That is my hypothesis. So I'm going to take my triangle and I'm going to mark that on the diagram. Remember, we identify congruency using tick marks. So I'm going to say one tick mark here and one tick mark here. Okay, now I have identified and marked the fact that two sides of my triangle are congruent. Okay, so what conclusion does that allow me to draw? Then the angles opposite the sides are also congruent. Okay, so that means I'm going to start on the right side because I feel like it. I want to find the angle that's opposite it. So I'm going to travel through my triangle. Do you see how that angle that I've arrived at is my opposite angle? And the angle opposite the other side, I know that those two angles are also congruent to each other. Of course, they are not congruent to the sides. You cannot have an angle congruent to a side. It doesn't work like that. Those two angles are congruent to each other. So that is the first theorem for isosceles triangles. And I'm going to shorten this by saying that base angles, because if you remember from 3.1, we talked about how those two angles that are opposite the legs are called base angles. Base angles of an isosceles triangle are congruent. Base angles of an isosceles triangle are congruent. Remember, these angles right here, those are the base angles. This angle right here, that is the vertex angle. Base angles do not have to be at the bottom, and vertex does not have to be at the top. It's about the relationship between the legs. So the vertex angle is the angle created by the two legs. The base angles are the angles opposite the two legs. Okay, now let's take a look at our other theorem, which is actually the converse of my first theorem. So this one says, if two angles of a triangle, are congruent, then the sides opposite the angles are congruent. So just like before, let's go mark that on our diagram. So two sides of a triangle are congruent. Sorry, two angles of a triangle are congruent. So I'm going to go ahead and mark this angle is congruent to this angle. That's my hypothesis. I have to know that in order to draw my conclusion, which is then the sides opposite the angles are congruent. So I'm going to again start at my angle and I'm going to travel across to the side. So I'm talking about this side right here. And I'm going to start at my left angle, my other base angle, and I'm going to travel across, and I'm talking about this side right here. I now know that those two sides therefore have to be congruent. So if you look at my two diagrams, they're the same diagram, okay? But the difference is the information that we are told versus the information that we can conclude. Our hypothesis and our conclusion, they've been reversed. So one is the conditional statement, the actual theorem, and the other one is the converse of that theorem. And depending on the information you're given and depending on the information you're being asked to find, you're going to apply the appropriate theorem. Before we do our examples, let's do one more theorem. So this theorem says, if a triangle is equiangular, now at this point you might be thinking, Mrs. Johnny, why are we talking about equiangular triangles? Didn't you say that this lesson was about isosceles triangles, right? Well, if you think back to our definition for isosceles triangle, we did not say exactly two sides are congruent. We said at least two sides are congruent, right? So let's see how this relates. So it says if a triangle is equiangular, then it is also equilateral. Okay, maybe you're like, I don't get it. Well, remember, if it says at least two sides have to be congruent to be considered an isosceles triangle, when all three sides are congruent, that's still considered an isosceles triangle. It's just a very, very special isosceles triangle. So this theorem tells me that all equilateral triangles are equiangular. All equilateral triangles, oop, I misspelled, are equiangular. Okay, let's go ahead and mark that on my diagram. It's equiangular, which means all three sides are, all three angles are congruent. It says then it is also equilateral, which means all three sides are also congruent. Now, let's look at the converse of that theorem. If a triangle is equilateral, then it is equiangular. Okay, and based on my diagram, that already makes sense. I can see that I've got equilateral triangle that is also equiangular, and I have an equiangular triangle that is also equilateral. So let me go ahead and break that down again. That tells me that all equiangular triangles are equilateral. Okay, now we're just going to do two examples and then we're going to make sure that you're able to do your assignment. Okay, it says find the measure of angle B given the length of segment AB is equal to the length of segment BC. Now, this is a part where you have to be very careful. It looks like, when I look at the diagram, just look at it, don't read anything. When I just look at it, it looks like this side is congruent to this side, right? That's what it looks like. But make sure you are reading, okay? Figure is not always drawn to scale. You got to make sure that you are reading the information that you are given and then using it appropriately. Okay, find the measure of angle B. So I know that I'm being asked to find this angle right here. So I'm going to put a little question mark and one tick mark, okay? And it says that the length of segment AB is equal to the length of segment BC. That tells me that segment AB is congruent to segment BC. Okay, well, what is segment AB? Segment AB is actually this one right here. Ooh, bet you didn't see that coming. And this one right here is segment BC. So my sides that are actually congruent are this one and this one. All right, you're like, okay, what do I do now? I know the measure of angle A, or at least I know an expression that's going to allow me to find the measure of angle A. And I also know an expression that's going to allow me to find the measure of angle C. Now think back to how an isosceles triangle is set up. The angle that is created by the two legs is the vertex angle, and the angles that are opposite the two legs are the base angles. And if you look back to our very first theorem says if two legs of a triangle are congruent, then the angles opposite those sides are also congruent. And then in parentheses we wrote base angles of an isosceles triangle are congruent. And if this is the vertex angle, that makes these the base angles. And so I know now those are congruent. So I can say 8x equals 6x plus 18. Quickly go solve it. If you solved it correctly, you would have gotten x is equal to 9. You're like, okay, cool. I've got the value of x. Does that help me find the measure of angle B? Well, of course it does. I got to think back again to 3.1 and think about the Triangle Sum Theorem. And the Triangle Sum Theorem states that the sum of all of the measures of the angles of a triangle are equal to 180 degrees. So what I can do is if I can find the measure of angle A and the measure of angle C, which we know are congruent, then I can add those up, subtract from 180, and that will give me the measure of angle B. So let's go ahead and do that. I can say 6 times 9 plus 18, which is 72 degrees. Now, you might be tempted to say, well, I already know it's congruent. And you're right, you do already know it's congruent, and you might be very, very confident in your work, but this is a very quick way to easily check if you did it right, because 8 times 9 is also 72 degrees. So you know for sure, okay, I solved my equation right because my two angles are congruent. So now I know that the sum of the three angles of my triangle are equal to 180. So I can set up measure of angle A plus measure of angle B plus measure of angle C. And you don't have to write this out. I'm just writing it out so you can see where everything is coming from, is equal to 180. So measure of angle A we just figured out is 72 degrees plus measure of angle B, which is what I am trying to find, plus measure of angle C, which is also 72 degrees, equals 180. And when you try to solve that, or when you do solve that, you would get measure of angle B equals 36 degrees, because you would combine those like terms that are 72 plus 72 and then subtract that from 180. And that is the measure of angle B. All right, now let's take a look at my other diagram. My other example says find the length of segment PR. Okay, my job, I need to keep this in mind, is to find the length of this segment right over here. Now, we don't know for sure that that is the side that's opposite the vertex angle. I've got to go and read. They tell me that the measure of angle P is equal to the measure of angle R. Okay, I've got to put that on my diagram. Measure of angle P is equal to the measure of angle R. Okay, awesome. This is looking like an isosceles triangle that I am kind of used to, right? I'm used to having my vertex angle at the top and my two base angles on the bottoms. Well, now I got to go think back to my theorem. My theorem says that if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So that tells me that this side is congruent to this side. Oh, I got a wavy line. Let me fix that. Otherwise, it'll bother me. Not much better. That's all right. We'll live. Okay, so I know that those two are also congruent. Well, if I can find the value of y, I could just substitute it back in and find the length of segment PR. So let me set my equation up. Y plus 10 equals 4y plus 1. Pause this video, solve it on your own. If you did it correctly, you will have gotten that y is equal to 3. Now I can just quickly go and substitute and get the value of the length of segment PR. I know that PR is equal to 2y minus 3. My y value is 3 minus 3. So PR is equal to 6 minus 3 is 3. If you have any questions, be sure to ask during class or come by for tutoring and get help, okay? Have a good night.